And welcome everybody to the Daily Space Weather. We'll be going at a high pace today because we're coming at you kind of late. It is a holiday after all, and happy Independence Day. More on that later in the video. We've got an active region setting up there in the northwest. The likelihood of large solar flares is very high, and the best news of all, we've got a coronal mass ejection headed our way. We can expect to see that impact the Earth sometime after midday on July 7th. So that's the past 24 hours from SDO 171 angstroms. Let's get a little closer to show some fantastic detail here from the Solar Dynamics Observatory. Here's the northern hemisphere. Again, eyes on that group in the northwest, which would be your upper right of your solar images there. We'll briefly zoom in on that location because, well, that is some awesome imagery. That depicts ionized iron, 171 angstroms from the SDO. The likelihood of this producing a large solar flare will wane here in about 36 hours, but for the next 24 plus, it still is very likely of producing a large flare, including the possibility of X-class solar flare events. Here is the southern hemisphere, and the coronal mass ejection that is headed Earth's way came from the lower left, the southeastern area. I believe it was the southern portion of the Alex Lifeson plasma filament, which we just recently named. So we'll be showing you lots more imagery here momentarily. And before we get into any of that, let's take a look at sunspots. Well, I mean, that's also fantastic imagery. That is yesterday plus today. Most of these sunspot groups here pretty stable. No major changes. It looks like one more group will get a name today. I don't think this group up here has a name yet. We'll cover that here in a bit. Here are the colorized magnetograms for July 3rd and July 4th to date. We do have more active regions rising there in the east as well as huge filaments. Let's see what's going on Earth briefly. Here's the situation for volcanoes. So Shivaluch remains on the list here. There's a great image of fumarolic activity at the Karan and Young Shivaluch lava dome areas. Not sure if it's producing an ash plume or not. Please do not pole vault the caldera. Mount Mayan continues to erupt and produce a 9,000-foot ash plume. Popocatépetl, 21,000-foot ash plume. Fuego in Guatemala, volcanic activity continues there. Sangay in Ecuador exploding, flight level 210. It's a 21,000-foot ash plume. Revenador, 15,000-foot ash plume over Ecuador, flight level 150. Flight level 230 over Sabancaya in Peru. As Sabancaya explodes. Ubinas also exploding in that same nation, 23,000-foot ash plume there. It's a flight level 230. And check it out, Erta Ale now back on the list, producing more effusive activity, and it's possible that the lava lake will envelop the cinder cone. So lava's oozing out there. The lava lake level is nearly 1 meter from the crater rim and may overflow it in the upcoming days due to the relatively high discharge rate of lava. Piton de la Fournaise on the Isle of Réunion also producing an effusive eruption there. And let's see what's going on for earthquakes. There is a 90-day graph to put earthquakes in context for the past 3 months. Here is the past 24 hours. Still significant number of quakes there in southern Alaska. Also on the west coast of the U.S., some quakes. We're going to cite quakes of a 5 magnitude or higher. South of Tonga, there was a 5.1 yesterday at 17:28 Universal Time. There was a 5.4 at Azerbaijan. That was at 2000. Actually, 20:01 Universal Time yesterday evening. Vanuatu had a 5.7 less than 1 hour later at 20:57 Universal Time. Tonga had a 5.3. That was at 4 o'clock this morning. I'm sorry, 0 dark 18 this morning. That 5.3 magnitude at Tonga. And that is the last one besides this 5.2 at South Sandwich Islands. That was at 12:01, just after noontime Universal Time, today on July 4th. And it's time to get back to space. Here we've added 304 angstroms to the 171 angstroms wavelength from SDO. That is ionized helium, along with the 171 angstroms ionized iron. And we're going to get to coronal holes and these other features here in a moment. 10.7 centimeter radial flux is now at 173 solar flux units. And let's take a look at solar cycle progression here for the past year. There is the 10.7 centimeter radial flux depicted by the black line. 173 solar flux units is the current 10.7 centimeter radial flux solar radio output. The pink line is the 30-day smooth sunspot number. The red line is the sunspot number. And that should be at like 185 or something like that. 183, something. It's, I don't know, it's behind. It's showing only 118 there. It should be about 60 sunspots higher than that. And let's take a look at Space Weather Enthusiast dashboard. Here's the NOAA forecast. And NOAA doesn't have any geomagnetic storms forecast. We're expecting a possible KP7 as a result of the incoming coronal mass ejection impact. Again, we'll show you that a little bit later in the video. First Earth's magnetic moment from space for the past 4 hours has been pretty chill. There is magnetohydrodynamic pressure depicted by the space weather modeling framework. So Earth's magnetosphere is about 12 Earth diameters in size. There it is from both the equatorial plane view, as if you're looking down on the planet, sun to your left, and the meridional plane view on the right. Here's Earth's magnetic moment from ground level. This depicts magnetic flux density for the past 4 hours. Again, things are calm on planet Earth at the moment. And that is going to change here in about 3 days. So we'll let that play through. Just a quick reminder, we don't see any quadrupoles or octopoles or hexapoles happening on this imagery. For everybody who's very, very frightened of the pole shift, the poles aren't all that weak from a historic geologic perspective. Next, KP index currently at 1. KP1 is the current situation. It is very geomagnetically calm on Earth. Next, a quick look at the solar wind is pretty unremarkable as well. Solar wind density here about 3.5 protons per cubic centimeter. Solar wind speed here about 350 kilometers per second. Nothing to write home about there. Let's take a look at the GOES magnetometers. Pretty smooth there as well. There is also a coronal hole stream headed this way. We'll get to that momentarily. First, our top view, look at the plane field plot. And yeah, we're still not at solar maximum, folks. We still are not at solar maximum. We've still got probably something like 9 or 10 months to go to get to solar maximum. So you can expect the better part of 2 years of these levels of solar activity or higher. So that's pretty cool. Here is our line of sight field plot. Earth is right in the middle of a North Pole current sheet here at the moment, as you can see there. North Pole current sheet depicted in green. This line of sight field plot also shows the solar magnetogram and plenty of magnetic organization on the Earth-facing side of the solar disk. Solar activity has been exciting, and you can only expect it to get more so. So there is the line of sight coronal hole plot, and these North Pole coronal holes are quite well defined, and we can expect a high-speed wind from those just after that CME impact. So we're expecting the CME impact to be a little bit ahead of that coronal hole high-speed stream. So both the 7th and the 8th likely to have some space weather events, which we are delighted about here at the Smash News Network. Least busted name in news. Now let's take a look at coronal holes from the SDO's perspective, because we've got some great imagery of that, as you may have come to expect from the channel. So there are those well-defined coronal holes, the source of high-speed solar winds. That's SDO 211 angstroms wavelength, another 24-hour video. And it's time to move to sunspots. So here's a sunspot situation. Again, likelihood of major solar flares very, very high, especially from this group right here. So this group over here That is sunspot 3354 is the main one. There are actually two groups there. 3354 is the larger group to the south. However, some of these other groups here are magnetically complex as well. And we just recently saw an M-class flare here as we recorded the show. So once again, the sun here chiming in. And let's take a look at sunspots from our custom videos. There's the past 24 hours from SDO Continuum. Again, mostly stable here. This sunspot group I don't think has a name yet, and this one down here might get a name. So we may actually see not quite so large of a sunspot downtick here with the setting of that group in the northwest. Again, there are more active regions there behind the eastern limb to your left. And let's take a look at solar flares and solar energetic particles. Goes proton flux here flatlined. We haven't seen a solar energetic particle event in some long time. We are well overdue considering the number of flares we've seen since the last solar energetic particle event. And there's the flare that happened while we recorded the show. That was an M1.3 approximately. Peak flux was around 1240 universal time. And let's take a look at our flare wavelengths. Keep in mind it's not going to show that flare because that happened after we requested these downloads. We will show you more current imagery though. That's the past 24 hours in SDO 134, 131 plus 94 angstroms. Here's a zoom out to the full disk view. And man, we've got plenty more SDO videos for you here. So let's keep this thing moving, as we don't want the video to be too lengthy. So here's what's going on overhead over Lehigh Valley, Pennsylvania. We like to use skyandtelescope.org to make our star charts. And just another quick reminder, I feel like a broken record here, but if you're viewing the dusk sky, go check that out, as you'll have Mars and Venus and a nearly full moon rising soon afterwards. So Mars and Venus will be very conspicuous there following sunset. Here's your solar system forecast. Here's where stuff is today on July 4th. Here's where things will be on July 11th. We will have a crescent waning moon by then. And let's move to coronal mass ejections. So here are yesterday's frames, CMEs. And let me get off the frame. There we go. So there's yesterday's coronagraph data set. There are some CMEs there, but the most important ones are today's. So that's 106 frames from yesterday. And here are an additional 27 frames from today. You can see this fanning out type appearance down here. That is the CME that is headed toward Earth, likely to arrive sometime later in the day on July 7th. So excited about that. We're not expecting it to be higher than a KP7, and there is a little bit of limited data on this, and we're going to show you some imagery that we do have so far. Unfortunately, the data is very old here from Soho Lasco C2 and C3, so that's not helping very much. We'll also show stereo A, which is also not helping very much. And we show this diagram to show the location of stereo A depicted by this red circle. Stereo A over here on the left, and also you can see Mercury there. Now keep in mind these are not synced, so you can see the time date stamps at the bottom. And let's see here. Soho Lasco C3 on the right is showing the preliminary portion of that CME. Unfortunately, stereo A, not so much. So right here you can see the last couple of frames. You can see that CME emerging out of the south and the east. And let's move to our custom videos. There is a 24-hour video. And you can we actually do have enough data there. You can see the initial portion of that coming out. A large portion of that will strike the Earth. It is not quite directly headed toward the Earth. Keep in mind, Earth would be moving from left to right from this perspective as it orbits the Sun. And we'll move in one step closer here before we show the region from which that CME came, which is right down here. All right, so here is the 193 angstroms wavelength by itself. And keep an eye on the lower left there. And there goes that CME event. Not very visible in that wavelength. It happened late last night, Universal Time. Here's a closer view of that coronal mass ejection. Right in there, that filament was sent in your direction, defying gravity as magnetic fields reorient, hurling that plasma toward Earth. We'll also show this area in the 193 plus 304 angstroms wavelength before we move on to filaments that are still intact. And there are plenty. Here's the full disk view. Once again, SDO 24-hour video, 193 plus 304 angstroms, ionized iron and helium. Let me just go back to this one real quick. That is a pretty sweet depiction there of that coronal mass ejection. You can also see some Hyder flare activity there. Some of that plasma splashed back down, and part of the Alex Lifeson filament looks like it's still intact as well. So let's move to filaments next. Here's the filament situation. And once again, thanks for tuning into the Smash News Network, least busted name in news. We're delighted that you found the channel, and frankly, we're surprised with the pathetic state of censorship on the internet. Yes. So we named this filament the Alex Lifeson filament because it looked like it had potential to produce a CME, and indeed it did. The lower portion of it is now headed toward Earth, so that's pretty sweet. This one over here is called the Bela Fleck filament, the famous banjo player and bassist, and that one is still intact. There are some large filaments in the northern hemisphere you could name after living people if you like also. Just follow us on Twitter and follow the hashtag #NameThatFilament. That's hydrogen alpha from El Teide, Spain. And again, likely still massive filaments here on the Earth-facing side of the solar disk. Expect additional coronal mass ejections and solar flares to follow. It's only exciting action going on for the next pushing 2 years. So here is the last couple of hours from the GOES 18 SUVI. And it looks like that M-class flare did indeed come from this area up here. So this will remain the most likely place to see a large solar flare for the next, again, about 36 hours. It is a very large, very magnetically complex sunspot group, and it's already produced an X-class flare. Don't be surprised to see more from that. And let's move to our bonus feature segment, starting with the satellite's community dashboard. We do have some significant surface charging hazards there over the southern Indian Ocean, Madagascar, and East Africa. Those are caused by high-energy electrons getting inside of the internal circuitry of satellites. Could cause some minor communications breakdowns there. Here is the GOES electron flux for the past 3 days. Back into warning territory there with the electron flux, and we've been in an electron storm here for quite a while. Again, there's the 3-day chart. We just showed the 7-day chart. Here is the 1-year chart. So surprisingly high levels of electron flux there. Those relativistic electrons of the greater than 2 mega electron volt power, those are measured at the F layer of the ionosphere, by the way. And there's the forecast. It looks like NOAA's going to be off here a little bit. And let's see. I suspect it's going to look more like this. But not too big of a difference there between NOAA's forecast and mine. So that's the relativistic electron forecast. Once again, that is measured at the F layer of the ionosphere. Feel free to pause the video on this frame if you're unfamiliar with the data depicted here, like electromagnetic radiation, atmospheric temperatures, and molecular concentrations. Here is the F layer and vibrational frequency, megahertz, millions of vibrations per second. And we're not expecting any major anomalies happening in this, but we'll show the anomalygram anyway because we archive this data. It's part of the purpose of these videos. We're archiving data for the past 6 years and tying it all together in one convenient video, showing all of the space weather data that I find to be relevant. We discovered that there is a hole in space weather coverage, and so we filled it. Here is the anomaly in megahertz from a 30-day median for the ionosphere. It depicts high-frequency anomalies in blue and low-frequency anomalies in red. Again, this is the layer where the GOES 16 and GOES 18 use radiography to measure the relativistic electron flux. They use radiography in order to do that from their geosynchronous near equatorial orbits. They're at like 23,500 miles of altitude, and they're measuring the electron flux at like 300 kilometers of altitude. Anyway, here's the latest image. This is 1330 universal time ionogram, and there's 1330 universal time anomalygram. We also show total electron content, another important space weather data set. This is shown because, well, it'll show you the most likely places to see GPS errors, folks. So once again, feel free to pause the video on this frame if you're unfamiliar with these distances in miles. Here is the total electron content forecast, showing you the most likely places to see GPS errors, and we are seeing some significant ones here over the Southern Ocean and Antarctica. So you'll see big anomalies happening down here. They are continuing here, so not only high electron flux, but also some anomalously high electron content there. So right in that area, you can see these significant anomalies around the Southern Ocean and Antarctica. And we'll let it play through one more time since there are some significant anomalies on there with the total electron content. It's literally a count of electrons from ground level to about 12,500 miles of altitude. And then we'll show additional detail here because if it's somehow relevant to anything, if there's predictive value, you never know. There's the total electron content anomaly from the 10-day average for North America. As it's becoming more apparent that there may be some signals here emitted by the Earth that show up in the space weather data that might have predictive value. I'll just keep it vague enough here that I don't wade into the weeds and make a fool of myself. So there is one significant signal right here over Central America, southern Mexico, right in there. So there is a significant high electron content signal. You can see over the Yucatan and it's just south of the isthmus portion of Mexico there. And we'll let that play through one more time. Keep in mind that is the electron content anomaly from the 10-day average, a count of electrons from the inner portion of the outer Van Allen belt down to your handset. Here is the latest intensitygram and latest colorized magnetogram. Again, we'll have one or two more named sunspot groups, also some active regions rising here. Oh, a new sunspot just rose. Check it out. There's a new sunspot. So that'll be one more sunspot group to get a name. And let us know in the comments if you think that's alpha class or beta class, especially if you understand the difference between alpha class and beta class sunspots. If so, why not leave us a comment and tell the rest of our viewers demonstrate your knowledge to the rest of our viewers about the difference between alpha and beta class sunspots. Next, it's time to move to meteorology. As I discovered about 20 years ago that it's way too easy to forecast the weather, so that's part of our value-added services. Yeah, the meteorology segment, and here it comes. First, we're chasing waves, and the seas are pretty calm here at the moment. It looks like the largest waves here are around the Southern Ocean there, the Southern Indian Ocean. There's a big area of high winds there and low pressure. So some big waves there, but they're not that big, only 26 feet. It's pretty smooth sailing for most parts of the world here. So that's depicting the surface wind speeds in the animation, and the color gradation is the significant wave height. So it looks like a good day for Viking raids for the most part. If you're planning on rowing a longboat from Scandinavia to Europe or the UK in order to pillage and plunder. Next, the surface winds of the eastern world. There you go. We've got a strong, oddly shaped low here, like a triple low, south of Australia. Here are the jet streams of this side of the planet. Still going backward over portions of the Indian Ocean. Here are the jet streams of the central world as we go west. Surface winds of the central world depicted here. Surface winds of the Americas. And these are the jet streams. Now today, since we're coming at you so late, we're actually going to show you something different here. We usually show the 3.9 micrometer radiation map, and we are going to show an animation here. First, the windy.com map. So that is depicting waves once again. Just wanted to show you that there are other ways to look at waves besides nullschool.net. Windy.com has a great mobile app. So there are those 26 footers that we talked about in the, well, that's the Southern Atlantic actually. Oh, looks like some good waves there on the southwestern coast of Australia. Anyway, this is the visible satellite for the Americas. And again, since it's so late, we can use this visible satellite for once today, bringing you something different instead of the 3.9 micrometer infrared radiation. I'll show the visible satellite instead. And it's light over California by now. Next, our weather.gov map. If your location is lit, head to weather.gov and click your location, the National Weather Service site, weather.gov. We've got some flooding and some heat watches and some gales and some high surf around Hawaii. Weather.gov is where to get your weather alerts. And first we'll show the GFS total accumulated precipitation forecast for the next 72 hours. Some heavy rains there coming to especially North Carolina, the southern portion of North Carolina there on around the coast, expecting like 5 inches of rain. Once again, GFS 72-hour total accumulated precipitation forecast in inches. Here is the GFS 72-hour pressure and precipitation forecast. There'll be some strong compact storms in the southeastern U.S. especially, also the central U.S. seeing some rather significant weather there. It looks like cold air pushing down from Canada, again, once again creating massive pressure gradients. Cold air, it's what causes tornadoes. And there you can see that cold air pushing down. This is your temperature anomaly forecast based on the same model, the GFS 72-hour temperature anomaly forecast in degrees Celsius. So those are some forecasts for you. Next, we'll show the state of affairs of lightning for the past about 10 hours. That's where the lightning's been striking. And let's look at the real-time lightning map briefly here. There is a real-time lightning map from lightningmaps.org. And here's me vanishing. Let's see if we have any terrestrial strikes. We do have some thunder showers there around, let's see, west of St. Paul and around Sioux Falls. Next time you hear thunder, check it out, lightningmaps.org. You can actually forecast thunder this way. It's pretty sweet. Today's featured merch product is MANSA, which stands for Make America Not Suck Again. It's up to you, not bureaucrats that can't get out of their own way or do their own jobs effectively. No, it's up to you, folks. You need to make your own little microcosm where you're making your part of America not suck. The Constitution, it still exists, and it's actually featured on this handsome graphic featuring the MANSA logo there in red, white, and blue fade. Happy Independence Day. We hope you are independent of fraud, propaganda, corruption, nonsense, corporatism, etc. We hope your disinformation has come to an end, although you are viewing this video on the internet, so we find that highly unlikely. MANSA, Make America Not Suck Again. It's up to you. SmashOmash.org is going to help make America not suck again. So support the channel via merch if you like. You can also support the channel via subscription services. The official subscription Let's try this again. The official subscription services site of the Smash News Network, least busted name in news, is smashomash.com/SmashTeam. So check us out over there. It should also be playing our Twitch feed, as we've been streaming the sun all day long because there's such a high likelihood of activity going on. You can find links there. You can find extra content if you're especially at the silver or better yet the gold Smash Team level. Smashomash.com/SmashTeam. We created our own subscription services site because, well, we needed to take our own path and have additional capabilities. You can find all the links there on the homepage at smashomash.com. So make sure you join us there. Smashomash.com is the official homepage of this channel. Visit our links. You'll find all kinds of additional content there exclusive to various locations. The Redbubble shop is linked, the YouTube channel, Smash Team, Hemp, Lucid, the Amazon shop, and lots more. So support the channel however you see fit. Thanks to everybody who has. And congratulations to everybody who's realized that the channel exists. Smashomash.com, smashomash.org will actually redirect you to the .com page. And here's the U.S. Doppler radar map. Here is the lower 48 map. Here is clouds and fog over the lower 48, and here is water vapor. And we've got a band of dry air stretching all the way from Baja California and beyond, all the way up to Maine. So a little ribbon of high-pressure dry air there. Also a low here. We do see some cloud nucleation happening down here in the central Atlantic. Also some rapid cloud nucleation happening in the Gulf of Mexico. Anyway, here's your recap. This shows vertical motion in the air column detected by ground-based Doppler radar systems. Minneapolis is about to get hit, and that's a significantly strong series of storms there making its way to Wisconsin. Here is the, once again, 3.9 micrometer infrared radiation. It shows clouds and fog even when it's dark. And there is the water vapor map, which should help solidify your ability to forecast your own weather. Anyway, thanks once again for tuning into the Smash News Network, least busted name in news. I've got to head back to the bunker because I'm independently frightened of space. Space. I'm very scared of it because I believe a lot of nonsense that I've heard on YouTube. Anyway, hopefully you're not consuming too much nonsense on YouTube. I'll be back tomorrow to cover the most detailed space weather content in the known universe and the most detailed imagery of the sun while I'm gone. Once again, happy Independence Day, and may that solar wind be at your back. Back to the... I'm going back to the bunker again. Whoa.